All right, so I said I'd go over a video going over the questions that you guys needed. I'm going to go through the solving of it pretty quickly because it's something that we've been doing for a little bit now, but take our time when we're going over the identifying the solution with our graphs. So from here, remember, if we don't see the word or, then it has to be an and statement, and that means it has to satisfy both inequalities at once. So I'm going to then rewrite this out. So we have 6a plus 6 is greater than or equal to 6. That's the red one I just underlined. And then we also have the other inequality here that we have 6a plus 6 is less than or equal to negative 30. So since I don't see the word or, I know it's got to be and plus it has to be and with the way it's written because it's in between the two numbers, so it has to be greater than or equal to 6 and less than or equal to negative 30. So even though something might jump out at you right now with the way I just said that is that even possible? Still go ahead and solve it because if that variable is a negative, it could flip some of those inequalities. It could make it so that it does give us a true statement. So let's go ahead and solve these though individually. So we have minus 6, so 6a is greater than or equal to 0. We divide by 6, so then we have a is greater than or equal to 0. And then we have minus 6, 6a is less than or equal to negative 36, divide by 6. So a is less than or equal to negative 6, and this is the word and in between. So now I'm just going to plot these 2 points. So we have negative 6 and we have 0. You're going to be creating your number line. So just make sure that you guys are knowing how to create that. This is going to be a closed circle at 0 because it's equal to, and since it's greater than, it's going to the right. This one's a closed circle at negative 6, and since it's equal less than, it's going to the left. So remember, when we're looking for and statements, we're looking to see where they overlap. Well, these two graphs don't overlap at all, so it means that there's no point that they share together. So there's no point that when I pick will satisfy both of these inequalities at once. So that means that it is no solution. All right, so now let's go ahead and move on to question number 6. I'm going to erase all this work though, so that way I have space to do number 6. So just make sure you go back if you need it. All right, so now number 6, I see this is a or statement. So remember, when it's or, we only have to satisfy one of the two inequalities at once. So I'm still going to go ahead and write them off on their own. So 5 minus 3n is greater than negative 10. And I'm just going to go ahead and solve it. So minus 5, so negative 3n is greater than negative 15. And when I divide by this negative 3 here, I just got to remember to flip the inequality because when we're dividing by negative, we're going to the opposite side of the number line. And those quote-unquote bigger numbers are actually less than on the negative side, whereas they're greater than on the positive side. So now we have n is less than 5, and then we know that this is an or statement. And let's go ahead and solve the other one. 5n minus 5 is greater than or equal to 35. So we'll add the 5 to both sides. So 5n is greater than or equal to 40. Divide by 5. And n is greater than or equal to 8. So then we just go ahead and plot these. So let's do 5 and 8. So less than 5, it's an open circle. Less than is going to the left. Greater than or equal to 8, it's a colored in circle. Make sure you're showing that. And greater than is going to the right. And this is our answer. So remember, for or, if they overlap, then that means that it's special. So we have to then see what does that overlap mean. When it's or, we just graph them. And if they don't overlap, these are our solutions because it only has to satisfy one of the inequalities at once. It doesn't have to satisfy both of them. So unlike the last one where they didn't overlap because it was n and was no solution, this is just the answer. All right, so moving on to question number 7. Once again, I see this as an or statement, so that's telling me some information about this. I'm just going to solve these individually. So let me just write this a little bit better. So we have negative 10 minus n is less than negative 12, or, and then let's go ahead and solve. So we add the 10, so negative n is less than negative 2. And now remember, right now we have it solved for a negative n, so I need to then divide each side by negative 1 to isolate or multiply that to make it a positive n, and now we're flipping our inequality and get n is greater than 2. And now we're going to go ahead and solve the other inequality. 9 plus 4n is greater than or equal to 21. So then we subtract the 9, so 4n is greater than or equal to 30. Divide by 4, subtract 9. So 4n is greater than or equal to 12, divide by 4, n is greater than or equal to 3. So now we're just going to go, don't forget it's an or statement, and we're just going to graph these. So we have 2, we have 3. So 2 we know is going to be an open circle, greater than is going to the right. This one here, we then have a closed circle, and greater than is also going to the right. So now that we have an or statement that is overlapping, we now have to think, okay, well, what does this mean? They're both going in the same direction. So that means then that it's not going to be all real numbers because any of these numbers over here aren't being accounted for. So can't be all real numbers. So then we look and say, all right, well, we only have to satisfy one of these. And I know any number I pick on this red one, all the green graphs is already included in that solution. So in math, we always just want to simplify everything as much as we can. So our final answer is just n is greater than 2, because since it only has to satisfy one of them, any number that satisfies being greater than 2 will already satisfy, or any number that's greater than or equal to 3 will already satisfy that n is greater than 2. So that's just our final answer. And if you wanted to go ahead, just make sure you're highlighting or regraphing or crossing out or circling, so I know that you know what your final graph solution is as well. So that would be our final solution there, because it only has to satisfy one of them. So since every single number that is greater than 3 is already greater than 2, that 2 will just be our final solution for it. All right, so now let's go ahead and move on to number 9. Same thing, highlight what it is. It's an or statement. So we're going to go ahead. We know we're just graphing this, no overlap. We know it's our answer, overlap, special. So let's go ahead and do 2x plus 7 is greater than or equal to 27. So we subtract the 7. So 2x is greater than or equal to 20. Divide by 2. X is now greater than or equal to 10. And now let's move on. 3 plus 3x is less than or equal to 30. Subtract the 3. 3x is less than or equal to 27. Divided by 3. That means x is less than or equal to 9. So now we're going to go ahead and plot those 2 points. Well, less than or equal to 9 is a colored in circle going to the left. Greater than or equal to 10, colored in circle as well, going to the right. This is our answer. There's no overlap, so there's nothing we need to really worry about with it, and just our solution, because it only has to satisfy one or the other. If your shirt needs to be blue or white, if you wear white, you're still good. If you wear blue, you're still good. If you wear both, you're still good as well, but you only have to satisfy one constraint for it. All right, and now we did go over number 10 in class, but you guys wrote this on there as well, so I'm just going to put on the video just in case as well. So when we do this, we have an or statement. So we have our first one of x plus 18 is greater than or equal to 8x plus 4. So I'm going to move my x to the left-hand side by subtracting 8x. So we have negative 7x plus 18 is greater than or equal to 4. Now I'll subtract the 18. So negative 7x is greater than or equal to negative 14, and divide by negative 7. So x is less than or equal to 2. And we know it's an or statement. So now let's go ahead and do the other one of 15x minus 15 is less than or equal to 15x plus 5. So we're subtracting 15x from both sides, and they cancel out. So now we have negative 15 is less than or equal to 5. Remember, this is an inequality. A lot of you are saying it's not equal to 5, so therefore it's false. We're asking, is it less than or equal to negative 5? So it is less than. So that means this is a true statement, which then means all real numbers. And since it is an or statement, it only has to satisfy one or the other. And even though every single number for this green graph is going to be less than or equal to 2, and no number greater than 2 will satisfy it, well, every single number will satisfy this one here. Whether I pick 100, whether I pick 14, any number that's greater than 2, it's always going to satisfy this one here. So our overall final answer is all real numbers. All right, that is it for this video.